bit rate is lower. Okay, so this will be starting in just 3 minutes. So we'll be starting the live in just 3 minutes, right? So at exactly 6:15 we'll be starting the live session. Yes, we are good to start now. So if you are having any doubts, please let me know in the live chat, right? So let's start this solving this problem just 1 minute away from 6:15 p.m. So we'll be starting with the today's lead code POTD problem. But let us start at 6:15 exactly, right? So that we can start at the time where we set, right? Just 1 minute away. So let us not waste our time and read the problem first. Count elements with maximum frequency. So it is marked as an easy problem. You are given an array nums consisting of positive integers. Return the total frequencies of elements in nums such that those elements all have the maximum frequency. The frequency of an element is the number of occurrences of that element in the array. This is quite an easy problem, right? It's just 6:15. Let's start solving our problem. So count elements with maximum frequency, right? So what is given in the problem? We are given with nums array, right? And also we need to get the answer. This answer is nothing but the sum of frequencies of elements with maximum frequency. So let us see what does this frequency means first. So let us take this example, the first example, 122 314. 122 122 3 1 and then 4. Now I have 1 for 2 times here, and then 2 for 2 times, and then 3 for just 1 time, and 4 is also for 1 time. So this is today's lead code POTD problem. POTD lead code, right? So I have 122 3 1 4. So 1 is present for 2 times, 2 is present for 2 times, 3 is present for 1 time, and 4 is present for 1 time. Now what is the maximum frequency that I got from all these elements, right? So the maximum frequency that I got is 2. 1 is not maximum. It is a frequency of an element 3 and also 4, but it is not maximum. So the maximum frequency I got is 2. Now What I said is sum of frequencies of elements with wait a second, it should be maximum frequency with maximum frequency, right? So I need to get the frequency, sum of frequencies of elements with maximum frequency. So I need those elements which are having maximum frequency, right? So let us see. One is having a maximum frequency of 2. So answer will be 0 first. Now as we are adding 2, so the answer will be 2. Next, we have 2 for 2 times, which is maximum frequency, right? So if I add 2 or 2, then I'll get 4. So the answer will be 4. Now let us look at another example where we have 1, 2, 3, 4, 5. Let us see now. Here I have 1, 2, 3, 4, 5, right? Now I need the maximum frequency, but let us say what is the frequency of 1. 1 is present for only one time. 2 is also present for one time. 3 is also present for one time. And 4 is also present for one time. And 5 is also present for one time. Now what is the maximum frequency? So the maximum frequency here is 1 itself. Everything is repeated for just one time. So what we'll do is just add to the answer those elements which are having maximum frequency. 1 is having the maximum frequency 1. So this needs to be added. 1 need to be added. So the answer will be 1, and then 2, 3, 4, 5. So the answer will be 5 at the last. Now we have got two things clear. First thing is we need to get, we need to know the maximum frequency, right? And the second thing, sum up the frequencies of elements which are having maximum frequency, maximum frequency. Now let us take by let us understand this by an algorithm, right? So let us take an algorithm. First thing, here I'm writing the algorithm. First thing, I need the maximum frequency. So what I'll do is I'll just store maximum frequency is equal to 0. Now I need to return the answer, so the answer is 0, and I need to declare n as the size of nums. N is nothing but size of nums. In your language you need to write as the syntax. Now I need the maximum frequency and also the answer. First thing, if I knew the maximum frequency, then only I can write, and then only I can go to the answer. So how can I get the maximum frequency? To get the maximum frequency, I need to store, I need to store all the frequencies, all the frequencies of elements. Uh, Let me write it as store the frequency of every element in a list in Python and a map in C++ or Java. Map is nothing but unordered map, right? So we'll be storing all these elements in a list or map. Now at the same time, we need to update the maximum frequency. At the same time, update the max frequency. Now there might be a possibility that we have we have only one element, right? 2 is the only one element. So what we'll do is just return nums dot size, right? Now we can also have 2 comma 2 comma 2. Here also 2 is present for 3 times. I need the frequency. So we'll just return nums dot size or size of nums according to your language. Now, let us see what happens here. First thing, at the same time, update the maximum frequency. I need to know if the size of list or map, let me name it as MB. Let me name it as MB is 1, then return nums size. So I'll just return the num size so that I can make sure that all the elements are equal, or I have only one element. Now, if we have different elements like 1, 2, 3, then we have three elements in our map. So this will not execute at that case, right? So first thing, go through the elements the elements in map or list. Now, if the element is having a frequency of max frequency, that's why we have updated the max frequency, then add it to add it to answer. At the end, we will return the answer. Now, let us take this algorithm as it is and let us write the code in C++. So I'll be coding in C++, but if you are a coder in Python or any other language, I'll just ask you or request you to know the syntax of everything that I am explaining now. So we'll be initializing max frequency, answer, and all. So let us take another color for this. Now, int answer is equal to 0. Max, let me write the max frequency first. So the max frequency is 0 and the answer is 0 and n is nothing but nums dot size. Now, store the frequency of every element in a list or map. So I need to initialize this MP. So I'll just use unordered map int comma int. Map is nothing but those which stores the frequency of every element, or we can also store the index. So this is nothing but a key and value pair. Now we have understood what an unordered map is. Let's go with initializing this unordered map with the name MP. Now, at the same time, store the frequency of every element in a list MP. At the same time, update the maximum frequency. So I'll just go through every element in nums for auto IT in nums. MP of IT is nothing but iterator which is going through every element in nums. Now MP of IT has incremented. Now the maximum frequency will also be updated with MP of IT. Why? Because MP of IT is storing the frequency of that element IT. Maximum of max frequency comma MP of IT. Now I have updated the maximum frequency till here. I have done till here. If the size of list or map, or I have set it as MP is 1, then return the nums dot size. So if list or map nothing but MP dot size is equal to 1, then return nums dot size. There itself, I'm just returning the nums dot size. Why? Because we have only one element iterated through many times, nothing but nums number of times, the size of nums number of times. Now go through the elements in map or list. If the element is having a frequency of max frequency, then add it to answer. For this I will be using auto IT is nothing but the element iterator with a frequency f. in MP, nothing but unordered map. So if MP is having these element and also the frequency, it go one after the another for every element it and with a frequency of f represents the frequency of the element it. If the frequency is equal to maximum frequency, then just add it to the answer plus is equal to f. F is nothing but the maximum frequency. You can also add the maximum frequency, right? So after that, return answer, right? So we can also, I think we can even optimize it, right? I think we can even optimize this code. So if you have any doubts or if you have the approach to optimize this, we are going through nums. Maybe it can take about bigger of n time. This will take bigger of n time, right? If in a worst case, if in a worst case, every element is having a frequency of only 1, then this will also take bigger of n time. Now, the time complexity is bigger of n plus bigger of n, which is bigger of n, right? What about the space complexity? There is a case that in the unordered map, we might store all the elements. That means every element is iterated or repeated for only one time. So, the space complexity we can use in the worst case is bigger of n. So if you are having any doubts or if we can optimize this, then let me know in the live chat, right? Yes, we can go to the next problem with a 5 minutes of break. It's just 6:30. We have just solved it in 15 minutes, but let us not take a break. Let us just code this. I have already solved it, but I'm just coding it again for your convenience, right? Let me check whether I am correct or I have done any mistake here, right? Now, let us start this. So let me end this problem at 6:40 or 6:45 at the time and restart at 6:50. So int max frequency is equal to 0, but have been typing this in this laptop for many days, so it is so fast to type in this, so it might take even lesser time. Int comma int mp, I have named it as mp for auto it in nums mp of it. So sorry, it should be mp of it plus plus. Now max frequency is equal to maximum of max frequency comma mp of it. Now, if mp dot size is equal to 1, then return nums dot size. Now, for auto it comma f in mp, if f is equal to frequency, max frequency, right? So we have solved this today's lead code POTD, right? Let us see whether I am right or wrong. I might make a mistake here, right? No, it got accepted. Yes, it got accepted. All the test cases has passed, but it's just 2 minutes, right? Not even 2 minutes, it's just 1 minute, right? So we have just coded it up. Now let's look at the contest question which was asked yesterday, right? Weekly contest 468. So I'm not solving this at the time of the contest. If you see, and it has already have been ended, the contest have been ended. So let us solve this first problem. I have already solved it, but let us solve it again. It is just an easy problem, a cakewalk uh, thing like problem. But the actual problems are the third and the fourth problem. In, if I am not wrong, it is yesterday's lead code contest, right? So let us see how can we solve this bitwise, or let me drag this whiteboard. It's a blackboard, right? So let us solve this problem. So what is given in the problem? And also I think it went away. So I have this bitwise OR of even numbers in an array. So I have made a mistake by taking XOR instead of taking OR. So we should not confuse at the time of contest or any online assessments. So for XOR, we will be using this symbol. This symbol, I think it's just like a cap. Or for OR, it is just a single line. Uh, it will be it will be like here. If you have the backslash in your keyboard, it's just the OR symbol. You might have knew this. So we are given an integer array nums. Return the bitwise OR of all even numbers in the array. If there are no even numbers in nums, return 0. So let us solve this quickly, right? Bitwise OR of even numbers in an array. And let us go to the second problem. Bitwise, I need to write the title of the problem. Even numbers in an array, right? So if you are having any doubts regarding this problem, I think you might don't have, or even if you are having, let me know in the live chat. Bitwise OR of even numbers in an array. So we are going with integer array nums and only do the OR operation with even numbers. If there are no even numbers, then you just need to return 0 itself, right? So what we'll do, we'll just write the algorithm directly. So we'll be initializing the answer is equal to 0. We need to do the bitwise OR with this answer every time we get an even number. So for auto it in nums. So what does this auto it in nums means? Every time when we use auto instead of int I is equal to 0 and all in the for loop, it means take the data type which this nums is having, take it automatically, and it will be pointing to the number in nums itself, right? So for auto it in nums, that's what auto it in nums means. Now if it mod 2 is equal to 0, then it is an even number, right? I'm just writing the code directly. So it is just an easy problem, no need to write the algorithm too. If it mod 2 is equal to 0, then answer or do an OR with it. Then after that, return the answer at the end. Let us do the same code, but I think there is no optimization. But if we have, without big O of n, we cannot solve it, right? So if we can solve it without this big O of n, I'm just taking this nums array, so it is just big O of n in worst case, right? For auto it, wait a second, wait, it in nums, if it mod 2 is equal to 0, then answer or bitwise or is equal to, answer will be updated with the answer or it, that bitwise or operation with answer. I'm just running the code. Yes, it got accepted. Now let me submit the code, right? So yes, it got accepted. So it's almost 6:37 now. We'll be restarting this. uh, we'll just take I'm just taking a break, but before that let me just uh, see what is asked in this problem. So if you knew that we can solve this problem even in the less time, then let me know, right? So I have this, but I have many screens here, maximum total and all. I think I have only one screen, right? So bitwise or of even numbers, no need. Maximum total subarray value. Yes, we are right. Now let us see what happens here. I'm just revising uh, in this live session. I have solved all these before the two problems. This one also I have already solved it if you see here. But the next two problems which that means for me it might be a great difficulty which was asked in yesterday's lead code contest. It I have already saw the problem and have read the question, but I couldn't figure out what's the approach for the problem will be. Now, let us come up with this problem, the latest problem in lead code in the contest. You are given an integer array nums of length n and an integer k. You need to choose exactly k non-empty subarrays nums L to R. That means from starting from index L till index R inclusively. Now, of nums of the given array nums. Subarrays may overlap and the exact same subarray, same L and R, if you see, can be chosen more than once. This is the most important thing which we need to notice, or which we need to uh, make sure that we have gone through the description clearly. So if it is right, if it is highlighted or it is in bold characters, then it is the most important for this problem. So the same subarray can be chosen multiple times. The value of a subarray nums L to R is defined as maximum of nums of L to R, maximum in that subarray minus minimum in that subarray. The total value is the sum of the values of all chosen subarrays. Return the maximum possible total value you can achieve. Let us take the example so that we can understand it clearly. Let me write it first here. So, uh, maximum total subarray value what? 3689. Maximum total subarray value. Maximum total subarray value 1. Right? Now, we are given with nums array. Let us understand it clearly. Max total subarray value sum. This is the first part. There is also the second part, but it is a hard problem and I think we need a sparse tree or advanced concept to solve that problem. Now let us think about this problem first. So in this I need L to R a sub array in nums. In the total array nums, I need a subarray from L to R. Here, I can get a maximum element or anywhere in this subarray, I can get a minimum element. Now, this subarray can be selected multiple times, right? Now, the difference between this problem and the second problem is only one thing, that we cannot select the same subarray multiple times in part 2, right? So we have the subarray, we have the maximum and minimum. We can select it multiple times, right? We need k subarrays like that. Now, why not select the same subarray again and again, as we can select the same subarray multiple times. Same subarray can be selected multiple times. Now we need k subarrays. Now I can get a maximum element and a minimum element. Now I need to get the maximum value, total value, maximum possible total value. How can I get the maximum possible total value? When I get the maximum element minus the minimum element. That's what asked in the question, right? So this difference into, I'm selecting the same subarray for k times. That's what we need to return. Now we might say that we need the maximum element, we might say that we need the minimum element, but how can I get the maximum and minimum element when we code? So maxi will be int min, which is nothing but the least element in integer range. Now minimum will be int max, right? So for every element for auto it in nums, maximum maxi is nothing but the maximum of maxi comma it. Now the minimum will be minimum of mini comma it. Now we'll just return as I said, maxi minus mini into, I am just taking the same subarray for k times, but for the second part it is quite different and also difficult, the approach, and it's not easy one, right? Long, let me take maxi is equal to, let me just take it as int itself. Int maxi is equal to int min, and mini is equal to int max, right? Now for auto it in nums, I'm just iterating through the nums array. Maxi is nothing but the maximum of maxi comma it, and mini is nothing but the minimum of mini comma it. Now return maxi minus mini into, I'm selecting the same subarray for k times. I might get a wrong answer if I am not wrong, right? So I have used the long previously when I submitted, but let me submit this here. Let me check. Yes, here I am getting maxi minus mini into k as a wrong answer, right? So what I'll do is just take this one LL. Let me check whether it runs or not. No, one LL is not accepted. Let me take long here, and also let me take long difference is equal to maxi minus mini, and let me take long answer is equal to difference into k. Let me just put it in a brackets. Here I'll return the answer. That's it. Let me check by taking this. I have initialized maxi. No, there is no comparison like maxi and it. So what I'll do, long. Let me take it is equal to uh, num. Now here I'll change it to num. Yes, that's what I did in the previous submission. If I am not wrong, let me just submit the code. Yes, it has accepted. Now let me check. I think I have missed something. I have missed a, yes, here. I have missed this. Okay. Uh, if you are having any doubts, or if you are looking for anything, wait a second. Here I need to open this. Yes. Let me just take it here and this here. I'm just switching the tabs. Now, let's go to the third problem. I simply didn't solve this problem till now. It is saying that BFS and all graphs. Okay, I might solve or not solve this in today's live session, but I need your help. If you help me out, then I can easily solve this problem. You are given two integer arrays nums1 and nums2 each of length n. You may perform the following split and merge operation on nums1 any number of times, right? So I'm also saying that I didn't solve this problem previously. It's a completely new problem for me. I have just read the description and also the examples, but couldn't figure out how to solve this problem. But with your help and with your suggestions, I might solve this problem today. Let us see what's given here. First thing, split and merge array transformation, right? So we are going with nums1 and also nums2. Let us see. Let us see. Right? Nums1 and also nums2. Split and merge array transformation. Now we need to make nums1 as nums2, right? So we are given with nums1 and also nums2. These two arrays with the same size, if I am not wrong. Yes, each of length n. You may perform the following split and merge operation on nums1 any number of times. Operation which is nothing but split and merge operation on nums1 to make it as nums2, right? So that's what given in the problem. Return the minimum number of split and merge operations needed to transform nums1 into nums2. Now let us see what is the split and merge operation here. Choose a subarray nums1 L to R. First, nums1 L to R. Choose subarray nums1 L to R. First thing, this is the first thing. Now let us see what's the second thing. Remove that subarray, okay, leaving the prefix nums1 0 to L minus 1, empty if L is equal to 0. So remove that subarray. We just need to remove that subarray, or we can get the prefix. We need to remove the subarray that's fixed, and we can get a prefix from 0 to L minus 1. Now the prefix might be empty if L is equal to 0. That means if we are taking the subarray starting from 0, then there will be no prefix. Now if I am taking this subarray, then there will be no suffix, right? Remove that subarray, that's it. Reinsert the removed subarray in its original order, excuse me, at any position in the remaining array between any two elements at the very start or at the very end. Insert it in the same order between any two elements, or first thing, between any two elements, same order, wait, same order between any two elements or at the start or at the end, right? So this is the operation which we need to do, which is nothing but it is quite simple. We are having this nums. Now I have this subarray. Now I need to remove this subarray and place it somewhere between these two elements, or anywhere between two elements in the same nums1 array, or I can place it at the start, or I can place it at the end, right? Now we have understood the problem. I have clearly understood the problem, but I don't have any idea about how to solve this or how to approach this. This is quite difficult for me. It is not even a medium problem. It is like a hard uh, one for me. Let me take an example. 3, 1, 2 is nums 1 and nums 2 is 1, 2, 3. I need to place with minimum number of operations. I need to make this nums1 and nums2, and the operation is nothing but take a subarray and place it somewhere in the nums1. Now I can take only one operation, right? So take this 1 comma 2 and place it at the start. Let me do it. 1 comma 2, this is the subarray that I have selected and placed at the start, and I have this 3. So I have this nums1 made as nums2 in just one operation. Now let me take another example. This is a quite disturbing example. Sorry, like an example which is quite very hard for me to even solve without a code or any approach. 5, 4, 3, 2, 1, comma 1. What I thought initially is we cannot do it in less than 5 steps. Why? Because I thought I have this 1 comma 1, I need to place it over here at the last. So for that one operation, 2, 3, 4, 5, 1 comma 1. This is the first operation. Now next, I got this 1 comma 1. Now I need 2, 3, 4, 5 in reverse order, right? So for that I thought this 2 need to be placed here, right? So then I would get 3, 4, 5 and then 2, 1 comma 1. Now I need to place this 3 here in between. So for that 4, 5, 3, 2, 1 comma 1. Now I need to place this 4 here, 5, 4, 3, 2, 1 comma 1. So totally this is the first operation, 1 comma 1 placed here. First operation, second, third and fourth. I thought I need 4 operations, but I am absolutely wrong with this approach. There is a way. 2, 1, 1 are at the same level, right? That means I'm just imagining it as they are at the same cluster or same group. Now but they aren't, they are in reversed order. 2 1 1 here and 1 1 2 here. 1 1 2 2 1 1. If I reverse this 1 1 2 to 2 1 1, then I would get it. Now the description says it as you got to 1 1 2 3 4 5, here 5 4 3 2, right? 5 4 3 2, right? So the description or the example did something very clear. 112, it took this 112 and placed it over here. Now let us see what happens if I do it. 3 4 5 1 1 2. Now the I didn't get the nums 2. I didn't change the nums 1 to nums 2 till now. I have 3 4 5 1 1 2, right? If I am not wrong, I have this like this. Okay. Now I have this 4 5 4 5, right? No, they just took this 1 1 2 not at the end. Instead they took it before 5, right? So they took it as before 5. So let me just take it here, and I have 1 1 2 and I have 5, right? Now let us see. 3 4 1 1 2 5, right? Now I have 1 1 2 and then 5. So they took the 4 1 1 again and 4 1 1 and made it over the last. 4 1 1 is at the last. Okay, take this 4 1 1 and place it at the last. Then I would get 3 2 5 4 1 1. If you see, I have this 5 4 and I have this 3 2. I can just take this 3 2 and place it over here. I have placed it over the end. I am placing it after 5 4. So I would get 5 4 3 2 1 comma 1. So how many times I have just replaced or did the split and merge operation. One time here, second time here, third time here. So it's open, the live chat is open for everyone. I didn't get any thought or any approach even after seeing nums2 is a permutation of nums1. Yes, they said that nums2 is a permutation of nums1 clearly. Yes. Now the length of nums1 and nums2 doesn't exceed 6. So if you see, it is said that nums1 and nums2 length doesn't exceed 6, right? So it's open, the live chat is open to everyone. We need to just interact with everyone. That's it. I didn't have any idea of how to solve it, and for sure, for sure, I need to, I need to, I didn't get uh, through the yesterday's uh, coding contest, right? So if you are having any thoughts about this, please let me know, uh, right? Please let me know in the live chat. So if we are having, so the acceptance rate is also quite low. So it should be marked as a hard problem in my opinion. So if you are having any doubts or I didn't even understand how to go through the approach. So if you are having uh, any approaches for this problem, so let me know in the live chat. So this is the problem, split and merge array operation. So it's it's quite difficult for me to even go through the approach or any. I didn't even have like I didn't have any thought about this, any thought process about this, right? So if you can share your idea or your thoughts for this, so it's open for everyone, right? Let us go through the number of topics. Right, it is only showing me that weekly contest 468. I didn't update the topics for it. Let me go with the first hint. So I am opening the first hint. Okay, it's a graph problem. Yes, absolutely. BFS over the space of array states starting from nums1 and aiming for nums2. So what a space of array states, right? What does this states mean? Array state of no space of array states. Let me take this example 1 1 2 3 4 5 1 1 2 3 4 5. This is the nums1. Nums1 is double 1 2 3 4 5, and I have 5 4 3 2 double 1. 5 4 3 2 double 1 double 1. This is our nums2. Right. So till now we have just solved three problems. Let me check how many subscribers we got. It's just I think 738. No, it's 741. Let us see in the live count. So can we hit 750 subscribers until we end this session, this live session, right? So we just need 9 more subscribers to hit 750, and it's just 75% 2000 subscribers. It's 750 is nothing but 75%. Now let us come to the problem. What I understood about space, I think it is nothing but taking a group, right? Space 5 4 3 2 1 1. It's quite uh, right. 112 here. Let us see 112. Now, to place it here at an index of, here I have 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Now, if I take 1, it need to be placed over 4. I'm thinking like that. This 0 need to be placed here, and this 1 need to be placed here, and this 2 need to be placed here, just here. Now, this 3 need to be placed here, that's it. 4 and 5, 4 need to be placed here and 5 need to be placed here. But even then, after figuring this out, I didn't get any idea like that, right? 0 need to be placed at, these 2 need to be placed at the end. Okay. That's the first idea. Let me check out the second thing. Represent each state as an array for tuple and enqueue it alongside its current operation count. I didn't even understand what does the state even mean or the space even mean. So if you are having any thoughts about this hint, please let me know in the live chat. Right? Yes. I just got 1, 1, 2, 3, 4, 5. Represent each state as an array or tuple and enqueue it alongside its current operation count. Each state, how can I select a state? That's where I'm getting a problem, right? Represent each state as an array or tuple and enqueue it alongside its current operation count. I didn't understand even a little bit. Maintain a visited set, a hash set, or dictionary keyed by the state to avoid revisiting the same configuration. No, I didn't understand anything. Even I didn't understand the state. But okay, I understood that we need to use a visited set and we need to implement the BFS. So let me write all these things. BFS, first thing I knew about BFS. So okay, I have solved problems on BFS, but I didn't know about this space or state. So this is the thing which I am having zero knowledge about. This is the first type kind of question, right? Visited set. I knew about this visited set. I can just take this visited set. However, I knew about this visited set. Let us see the, for each dequeued state, generate all possible split and merge successor by choosing every valid subarray, removing it and inserting it at every possible position. Generate all possible split and merge successors by choosing every valid subarray for each dequeued state. No, I didn't have any idea of it. Any idea of it. Stop as soon as you dequeue nums2 and return its associated operation count. Okay. So we can get to the nums2 as you dequeue nums2, right? Okay, but how can I select a state? That's where I'm getting the problem. Let us go to the discussion section. Looked so easy, but couldn't even code a single line for the solution. Second question, hello sir. Third question, I started at this state at this question in the contest for almost 17 minutes straight without writing a single line of code. Okay. From the discussions, we can uh, get it right. Okay. Some of them are exploit the constraints. Yes. We have this 6, but how can I get the state? That's where I am getting the problem. That's where I'm not understanding how can we solve this problem, right? Thank God n is less than or equal to 6. Yes. For those people who are asking why BFS or DFS, it wasn't about that. I just did recursion and pruned it. Recursion, just did recursion and pruned it and used some visitor table. It ended up being a BFS. And anyhow, we only have 6 members, so just brute force your way through it. Let us see. Okay. 1 1 2 3 4 5 5 4 3 2 double 1 1 2 3 4. Why did it came here? 1 1 2 3 4 5 and 2 3 4 5 double 1. Let us see how can we. I think we can use recursion. 1 1 2 3 4 5 uh, 5 4 3 2 double 1, right? 5 4 3 2 double 1. Okay. Now I have been taking it as a recursion. Let us do a recursion. How does this recursion works? Or even I don't know like that, but I need to take a state, right? So what I'll do, I'll just I'll just take this one element and then two elements and then three elements, 4, 5 and 6 at max. I have 6 elements, right? So if I take 1 and where do I place it? So I have 6 possibilities. Index 0, this is at index 0. I can place it 5 possibilities at 1 or at 2 or at 3 or at 4 or at 5. Now I have this 1 again at index 1. I can place it over 0, 2, 3, 4, 5, right? I have another group 2 3 4 5, same thing, 2 3 4 5. This is a group. I am selecting this as a group, right? Now I am placing it over index 0 1 3 4 5. But first thing, let us see how it was solved in the example, and we can go by it. Remove 1 1 2 at index 0 to 2. So we'll be selecting a group of size 3, 1 1 2. Now where can we place it? That's what the question is. Can we place it after 1 or can we place it after? No, we can only place it after index 2. Now we cannot place it here. If you see, wait a second, 0 1 2 3 4 5, we need to place it after 3, right? So I'm saying it as after 3, after 4 or after 5. So 1 1 2 need to be placed, can be placed after 3. Let me write it here so that you don't confuse. After index 3 or after index 4 or after index 5, right? So these three. Now so what did they do? They placed insert at position 2, 3, 4. After index 4, they have placed it over here. Let us do the same thing after index 4. Then I would get the nums array as 3, 4, 1, 1, 2, 5. 3, 4, 1, 1, 2, 5. This is the nums array. Now every time they get the array and then they select a group of different sizes 1 2 3 4 5, but I got the intuition, but solving this is, I think this code for the algorithm or even the code, it might take much amount of time. Okay, but let us try it. Remove 4 1 1 at index 3, insert at position 3. Let us see. 4 1 1. Let us take this 4 1 1 of group 1 2 3 4 5. That's it. We cannot take a state of 6 and place it somewhere. It will be the same thing, right? Now I am taking the group of size 3 4 1 1. Where I have to place it? At position 3 0 1 2 3. No, at position 3 means I need to place it after 0 1 2 3 4 5. So as I said, I can place it after 0. I cannot place it after 0, right? It is already there after 0. I can place it after 3, right? After 3 I think it's the same thing. 4 1 1. No, insert remaining is 3 to 5, so remaining is 3 to 5. I am placing it after 5. Place it after 5, right? Then I would get it as 3 2 5 4 1 1, right? So if you are new to our channel, please do subscribe to our channel. So let us see whether can we hit 750 subscribers till we end this session, right? It's already 7:30. It's already been 1 hour, right? So I got this 411. Till now I didn't get it equal to nums2, right? Now let us take another, remove 3 comma 2 and place it over here. So let us take this indices again, 0 1 2 3 4 5. But if we are removing, I think I need to just brute force it by removing. We need to actually remove it. Let us see. Let us see by taking 3 comma 2, removing this 3 comma 2. Then I would get it as 5 4 1 comma 1. Now the indices are 0 1 2 3. Now I have this 3 comma 2. I need to place it somewhere. Now I have 4 options. Let me take this 5 3 2 4 1 1 after 0, but it is not as we are saying it. So it can be before 0, right? 3 comma 2 5 4 1 1 and 5 comma 3 comma 2 4 1 comma 1, 5 comma 4 comma 3 comma 2 1 comma 1. This is one possibility. This is one possibility. After 4 I have placed after 4. I can place after 1, 5 4 1 3 comma 2 comma 1. This is one possibility. 5 4 1 1 3 comma 2. So I can place before 0 or after 0, just after 0, or just after 1, just after 2, just after 3. So I have the number of possibilities like this. Now the thing is, the even the algorithm feels so difficult for me. Let me write it. However, every time every time select a group of size 1 2 and so on till I can take n minus 2. The size, the maximum size I can take is n minus 2. Why? Because if I have 1 4 5 6 7, I cannot take the whole array and place it like somewhere. There is no change in that. So I'll just take till n minus 2. I think so. No, it is not n minus 2. It will be n minus 1. 1 5 3 4. The total size is 4 and I can take 3, right? 3 is nothing but n minus 1, 4 minus 1. So I can take 1 to n minus 1. Now I need to take a subarray, right? So iterate size is equal to 1 till n minus 1. I have different sizes. Now iterate, right? So let us take size is equal to 3. Now let me take how far I can go for taking a subarray of size 3. So this is the yesterday's liquid contest problem. 467, I think 468. Yes, 468. Okay, the third problem, size is equal to 3. Let us take the size n is 6. Let me take 1 3 5 4 6 2. Now size is 3, right? So let me take the indices as 0 1 2 3 4 5. Now I can get this also. So I can I need to stop less than 4. How can I get this 4? 6 minus not 4. 6 minus 3 is 3 plus 1. So I need to stop at uh, n minus size plus 1. Okay, n minus size plus 1. This is just an example, that's why I took it, right? Let me just change the color from green to white. Okay, I have changed it to white. Let us see. Iterate size is equal to 1 till n minus 1, right? Now index iterate the start index, let me name it as start index, starts from 0 and goes till n minus size plus 1, less than n minus size plus 1. Now I can go till n minus 1, right? But less than or equal to. Instead, let me write it as n, less than n, right? The size can be less than n, nothing but uh, 5. It can be 4. I can take the size of 4, the nothing but a state. Start index is equal to 0 and less than n minus size plus 1. Now I've been iterating through it, through the size and set index from 0. And what I'll do, I'll just take a state vector of int current state, and I will place this current state is nothing but, let us just take this as, okay, this current state made of made from made of array elements starting from starting from start index and with a size of size. That's it. I have this size, right? I have this current state. Now I need to remove it and place it somewhere. So I need to remove this current state. Remove the current state and call for recursion. Call for recursion. Here comes the actual thing. So every time the size will be iterating from 1 till less than n and vector of int current state, iterate start index is equal to 0 and less than n minus size plus 1. I got the current state and remove the current state from the array and call for recursion with the changed array and current state. So the changed array will be having less size and the current state will be having a array. Current state is nothing but an array. Now in the recursion, what we'll be doing in the recursion, I need to know this also, right? So this is the recursion which we are doing. This is the recursion which we are doing, right? Let me just remove it from here. This is the recursion from which we are doing. In this recursion itself, in this recursion itself, first start with place the state before the changed array. Before the array, let me just name it as array. Now place the state after every index, and do this, iterate. So place the state after every index, uh, and and call for this iteration. Nothing but place the state before the array. Before the array itself, I am placing this state, the state which I got. So in this recursion, I get state is nothing but the cluster or subarray which I am taking and replacing somewhere. And I had this state, and also the array, it might get changed, and I have this nums too, right? So the first thing which we need to check, if by placing it like that, if by placing it like that, if array uh, array after placing array after placing is equal to nums2, then return number of operations. So for that, I need to also maintain, remove the current state and call for recursion, and state changed array and operations plus 1, not plus 1. Here we need to return the number of operations. Here also I need to make sure I have the number of operations. So this is how you excuse me, this is how you get the algorithm. Let us see even how can we solve this, but let us see, right? Split and merge array operation. Let me just take a 5 minutes break. You can also take the break. I think uh, you're also very tired by listening and solving these problems, right? Okay. So can we hit a 750 subscribers till we end this session? We just need 7 more subscribers. 7 more subscribers to hit 750 subscribers, right? Let's look at the channel analytics here. Let us see the streams. It is showing something like this. Let us see what it is. No, I need to top chat and live chat. They are different. Yes. So you can take a 5 minutes break, and also for me a 5 minutes of break, right? Open it. No. So we will be starting this way in just 4 minutes at 7:30 p.m. exactly. right? Yes. So if you are having any doubts, please let me know in the live chat, right? We are just waiting for 750 subscribers, not 750 subscribers, but 7:30 p.m. 743, and 70, right? Split and merge array operations. We are going to solve this problem, and we have just figured out the recursion, but I think it might not work. Why? Because for this 6, we are taking bigger of 5, right? 5 times and then iterating for 5 times. Even if we are doing like 5 for, are you graduated? JS anime. No, bro. I'm in my fourth year of BTech, 7th sem. So thanks for watching this live, JS bro. So let us see, can we hit 750 subscribers before we end the session, right? Now we got this recursion algorithm. That means I'm not pretty sure about to solve the problem, but it's a new problem for me. This kind of problem is a new problem for me. So let us see, right? Yes. Uh, so if you are having any doubts, please let me know in the live chat, right? Yes, we'll be starting in just 1 minute. Can we solve this with this algorithm? What are your thoughts on this, right? So we just need 6 more subscribers to hit 750 subscribers today. So it's just 22nd September, right? Right, it's just okay. Just we need to get the state, right? We need to get the state first, and array which we are changing, right? The state is nothing but a cluster or a subarray. Now array is nothing but the nums1, and we have nums2, and also operations is nothing but the count of the number of operations, right? Place the state before the array, that's the first thing. And also if array has if array after placing is equal to nums2, let me write it clearly. Even I can't understand, right? Let us just write it clearly, and then we can expect, we can get it done, right? So let us just write it more clearly. First thing, first thing is, let me write it step by step. First, uh, everywhere a group of size 1 2 until n minus 1. Now recursion, we have started with the recursion itself. Recursion, what does it take? It take state, array, nums2 and operations, nothing but the number of operations. What is this state mean? State mean the subarray, right? Subarray that is replaced, that replaced, right? So this is weekly. Let me change it. Weekly contest 468. Yesterday's. Okay. Lead code weekly contest 468. Now I have this recursion state array nums1 array that has to be changed, that has to be changed to nums2. Nums2 you already knew it. Nums2 is already given. So this is our third problem. Third problem. This is a DSA problem, right? So we can call it as a problem. Now recursion state array. We have new what array is and we need to know operations. Number of operations. Right. Now we knew every element in the recursion, the state, array, nums2 and also operations. Place the state before the array. Let me write the same thing here. Place the state before the array. Before the array. Now, if new array is equal to nums2, then return, you just need to return the number of operations. That's it. Now, if not, place the state after every index. Second thing, iterate through every index and place the state after every index. Now, after placing it, just after placing it, if new array is equal to nums2, then return the number of operations. But before that, we have placed the state before the array. We also have to call for the recursion, right? So iterate through every index, right? So instead of writing like this, let us write it as let's write it as before the index, state before the index, right? So we'll be stating before every index. So if I am having 3 5 4 and I have 1 comma 2, I can place it over here, I can place it over here, I can place it over here, and I also can be placed it over here. So the number of instances are 0 1 2 and I have 3. So I can place before 0, I can place before 1, I can place before 2, I can place before 3. So every index, so I'll index will be starting with 0 and going till less than or equal to size of array, size of array, right? So if new array is equal to nums2, then return number of operations. Now if new array is equal to nums2, return number of operations, right? I have placed before every index That means before the array and also after the array I have placed it. Now place the state. Okay, if array after placing is equal to nums 2, let number of operations, iterate size is equal to 1. Another iteration. Another iteration here. Here iterate with size equal to 1. With size equal to 1. With size is equal to 1 and going till less than n. Nothing but n minus 1 size will also be considered. Now vector of int current state. This current state uh, will be changed to uh, array, right? So this new current array or current, let me say it as current array instead. Current array, right? Iterate size equal to 1 till n. No, it would be state, right? Current state, sorry, this current state will be passed as a state. Now we have created a current state. Now another iteration, iterate start index is equal to 0 and going till less than n minus size plus 1, right? So you need to iterate it, and here if you see current state made of array, let me write it again. Current state is made of array. Let me be clear, it is sub array and elements starting from start index and end with size. Okay, sub array with size starting from start index, nothing but stidx, right? Okay, current state, I have initialized the current state. Now remove the current state and call for recursion. This is one thing, and remove the current state from temporary array. Now let us take temporary array is nothing but the same array. So that we are taking this temporary array so that we don't change the actual array, right? So temp array is equal to the given array. Now remove the current state from temporary array and call for recursion. Recursion, what is the state? State is current state, and after that current state I have the array. Array is nothing but the current temporary array. Now after temporary array I have nums2 and also operation. Nums2 and also operations plus 1. So this is the recursion with the iteration, right? Here it will be iterated. Now after this will be closed, and also here this will be closed. I think it's quite clear. So iterate through every index and place the state before every index. So index will be starting from 0 till less than or equal to size of array. So if you are having any doubts, or if you are uh, if you can share any thoughts about this problem, please let me know in the comment section, right? So but before that, before winding up this session, so let us see, can we go with 750 subscribers till we end this session by 7:45, just 4 minutes, right? So you'll be getting the content of DSA every day, right? I was suffering with fever and also cold, so that's why I can't and also I didn't make videos or explanations in this YouTube channel, right? So I hope you understand, and please let me know if you are having any doubts and if you want to share something with me, right? We'll be ending this session in just 3 minutes, right? So we just need 6 more subscribers to hit 750 subscribers as today's target, right? So let us see, do we have anything like weight scale? Yes, it is in the same order. Okay, this is a quite large algorithm and I also could solve this problem today, and I have figured out the algorithm but could not code it out. So I'm sure that I'll get the code. There are many people away, right? But I'll be getting the code and also solving this tonight, and I'll be sharing this in the LinkedIn too. So let us see what the discussion tabs say. I have stopped here itself. How come you people thought of BFS? Was there any pattern or clue? Man, this is so tough. I literally gave up the number six was. Yes, I do gave up on this problem. The number six was forcing me to think brute force. But I don't know why I was thinking that answer might not even go to six. I have to just think around one, two, three, and cases. But PFS on this damn, I gonna give up on reading the editorial too. Okay, one of the trickier problem, in my opinion, hard to see its graph. Okay, so okay, this was a hard problem for me and also for other people, other coders, as I'm going with the discussion tab, right? I got the intuition and knew it that I have adjust every summary and every size of every place using BFS, but was not able to implement it. Use ChatGPT for implementation, of course. Haha. Int n is equal to nums1 dot size, the only line I could write. Okay. सुबह सुबह 2 मेगापिक्सल का कैमरा लेके. The only hint you need, instead of trying to generate all permutations using DFS, generate all permutations in DFS. Instead of DFS, you can use BFS, right? Okay. And so you can exit as early as possible. During the contest, I got 360 by 535. Then I gave up. This is the 360 number test case. Nums1 is equal to 24 minus 98 and 98. Nums2 is equal to 98 minus 98 and 24. Output is 1, expected is 2. So we'll be ending the session here itself. Thanks for watching the live, and if you have any doubts, please let me know in the live chat. Thank you.